STEM science.
All right, here is our fourth type of charging. This is again charging by induction, except this is going to result in a charge that is going to be permanent, meaning that this is a charge that will stay even after this charge object leaves. And again, just to be absolutely clear on this is charging by induction. So these two objects, this charged object here and this neutral object here, are never going to touch. All right, this is not charging by contact, this is charging by induction. Now, the other thing I want to point out here is you'll notice that we've got this weird looking line sticking out the side here going down. This symbol here, I didn't draw it the best. Let me see if I can actually try to fix that up a little bit. This is really trying to indicate that this is a connection to the ground. And what that means is that this is basically a pathway for charges, negative charges, to move either into the ground or up from the ground. Now, why is the ground so important? Because like I said in class, the ground, the earth, basically is this huge reservoir of charges, both positive and negative. And as a result, when you start to have positively or negatively charged objects and they need to pull stuff or if they're looking for electrons, it's going to find electrons in the ground. A negatively charged object, which maybe wants to get rid of electrons, is going to have no problem giving the electrons to the ground because the ground, the earth, is a great place. It's a huge bathtub of charges, and it's a place where charged objects can either pick up negative charges or get rid of negative charges. So that's an important point here because what's going to happen is this. When this negatively charged object, again, notice the abundance of negative charges compared to positive charges. When this negatively charged object gets close to this neutral object, it is going to, again, push or repel the negative charges in this neutral object. Again, this is very similar to what we saw in the previous example of charging by induction, creating a temporary charge. But what's going to happen here is it's this connection to the ground. Not only will these negative charges sort of be repelled, but they now have a way to sort of get out, and they will sort of go this way down and into the ground. And in fact, so long as that negatively charged object is sitting there, these electrons are all going to start to sort of get repelled and start using this connection to the ground as a way to get even further away from that negatively charged object. And there they go. That's it. Beautiful. And yes, sure, we'll put in another one there like this. And it'll continue going on like that. So you can imagine there's this huge exodus away or out of this neutral object. Now, look what's happened here. We've got the situation where we have this sort of object, this once neutral object, has now lost its electrons into the ground. Now, this is really a positively charged object. And in fact, if this charged object were to sort of move out of the way and leave the vicinity, what would basically happen is that these negative charges would just simply sort of come back up from the ground. They would say, okay, great, now they're sort of getting attracted by this sort of positively charged object that once was a neutral object, and it's going to sort of bounce itself out and become neutral again. So that's what's going to happen there. But what if we kept this negatively charged object really close, and we want to try to keep this as a positively charged object? How could we prevent these negative charges to simply come back into here once this negatively charged object sort of left the vicinity? Well, the one thing we could do is if we disconnected it. If we disconnected the ground connection from this object here, from this once neutral object, now once this object, this negatively charged object, leaves the vicinity, there it goes, bye-bye. These negative charges here, that once were part of this neutral object, cannot come back. They will not be able to return. And as a result, you're left with this positively charged object. So just to recap, this is what we started off with. We had a negatively charged object coming close to this neutral object. This neutral object, because it had a connection to the ground, lost the electrons because they're all being repelled by that negatively charged object, sort of escape into the ground. If we disconnect the ground connection while this negative charged object is still in the vicinity, We then prevent the electrons or the negative charges from getting back into here once this negatively charged object sort of moves away and is removed. And what you're left with is a positively charged object. Now that is charging by induction resulting in a permanent charge. The question might be, well, does that same thing happen when you're dealing with a positively charged object? Yes, but make a note of what's going to happen here. Here is a positively charged object. Here is our neutral object. There is our trusty connection to the ground, all right? And again, like I said, we've got this reservoir of charges, positive and negative charges in the ground, in the earth. So when this positively charged object starts to get close to this neutral object, again, it's only the negative charges that can sort of move or shift. And because these things aren't actually contacting with each other, the best that these negative charges can do is actually just sort of try to collect and try to get as close as they can to that positively charged object. And as a result, you can see them sort of all gathering around there. They're all sort of looking to get close to that positively charged object. Not only that, because this is such a positive charged object, you're going to start to have sort of more electrons down it from the ground sort of come up here because they also can sort of get attracted as well. And you can see that these guys start to come up like this. And we might just do one more. So it comes up from the ground through that ground wire and into here like this. Let me just be as accurate as possible. There it is, up from the ground and into here like this. Wow, look at that. And again, if we were to disconnect this ground connection while this positively charged object was still close, once this positively charged object leaves the vicinity, these negative charges that came up from the ground are not going to be able to return to the ground. And as a result, you're left with a negatively charged object. This is called charging by induction, resulting in a permanent charge, except this time we looked at it when we have a positively charged object coming close to a neutral object that's connected to the ground. And if we time it right, if we do this in the right order and disconnect the ground at the right time and then remove the positively charged object, we will then be left with a negatively charged object. So for this, just to recap, this is what we did. Positively charged object comes into the vicinity of a neutral object. That then results in the electrons being attracted to the positively charged object. As a result, even more electrons from the ground come up to join in. And when we remove that ground connection and then remove the positively charged object, what we're left with is a negatively charged object. So again, starting with a positive object and a neutral object, we're left with a positive object and a negatively charged object. So that's charging by induction, resulting in a permanent charge.